Hello everyone, welcome to Easy Learn. Today we are going to start the chapter Diode and Applications. This is the second chapter on this channel. The first topic on this chapter the first topic diode, the diode. One thing I want to tell you here, if you want to learn the basic about how the diode is formed, then I recommend you to watch Introduction to Electronics chapter. All the episodes are available on the same channel, and in that chapter, Introduction to Electronics, all the basic things were discussed that I am not going to explain in this chapter. As you know, a diode is made from a small piece of semiconductor material, usually silicon in our case, because we will focus on silicon, not germanium. I already explained it in my previous videos. So silicon, in which half is doped as a p region and the other half is doped as an n region. Okay, first I'm going to draw this diagram with the help of diagram. For example, this is this is a material, and half of it is doped with a p type. This is p type and this is n type, and this is, for example, I say this is a depletion region. If you want to know what is a depletion region and how it is formed, how the transfer of the charge take place, what is electron current, what is hole current, I think these all things are basics, and I already explained in my previous chapter. Total 13 episodes already available on the same channel. Watch this if you further want to clarify. If you already know the concept of these things, then it is a well and good thing, and we will continue to our topic easily. This is the depletion region in this P and N type. Between the P and N type there is a depletion region. One half is doped here, P type material, and other is the N region, and the P region is called the anode. There is a metallic lead too. There is a metallic lead, for example, metallic lead. This is also metallic lead. Okay, this is the depletion region highlighted, P type, N type, and I told in the previous videos how to remember easily the P type and N type. This is the positive. Either there is a confusion if you have this is positive or negative, or this is positive to negative. There is a very easy way to understand this. This is a positive. P stands for positive and N stands for negative. P stands for positive and N stands for negative. Very easy to learn. Next, this is as you know, we called the positive side the anode, and negative side we know that it is a cathode. This is anode, this lead is anode, and this lead is metallic lead is cathode. So the N region is cathode, P region is anode, and these things configuration is like that. The both of these are connected to the conductive terminal, both to the external source with the battery, and this one side, for example the anode is connected to the one side of the conductive terminal, this anode, and the N region, or you can call the cathode, which must be connected to the second conductive terminal. I am going to now draw the symbolically diagram. This is general diagram and for understanding, and here it is another diagram which is like the this the arrowhead, and here is a small line. This is the diagram. We can share it, fill this to. This is a cathode, the tip of this arrow, and the back side of this arrow is anode. Anode and cathode. This is symbolically representation. One thing I want to clear here, that I am picture of typical diode packages with terminal identification are available on our Facebook page. I will upload the link in the description. Their anode is represented by the capital letter A. For example, let's draw a rough diagram of how the diodes are nowadays available. This is I am going to draw a very common diode that is usually used in every circuits, mostly circuits. This is a simple, this is a diode when you calling that. This is usually a black, and this is, for example, this is a diode. It's one pin, two pins are there. How to identify that which side is a positive or P type or N type? There are very some on this type of diode there is a band here in this case, and there are many types of diodes are available. Some has holes on their head, or some has a cap on one side to identification of the P and N region. Here in our case that I am discussing a simple and the most general P-N junction available in this case. You know that a band is available in one side, and on that band, this band basically is used for the identification. This band basically used for the identification, and it is cathode. It usually shows that this pin is cathode and this is other is anode. The interesting thing I want to explain, the purpose of to draw this is to explain the anode and cathode. There I will upload a picture. There mostly in all the books we use, we also, and all the books most commonly use is for anode representation capital A letter, but for cathode they didn't use the C letter, capital C letter, but they use the K. This is very important thing. Mostly students are basically think that why it does not use the C and used the K letter. There is a justification is very simply that to avoid the confusion with certain electrical quantities that are already represented by the C, capital C. So if we use C here too, it will create a confusion. So to avoid the confusion, K is used. Now there is two types of, if we want to bias this, means to say if we want to provide the electric current to its terminals. There are two terminals are available. If we have a battery DC source, if we want to bias with a DC source, there are two conditions. For example, I connect the positive terminal with this lead, or with the P type, or the negative terminal with the N region, or this metallic lead. And another option is to connect the negative lead to this side of the and the positive lead of terminal of the battery must be connected to this side. There are two types of options are available for me. So I will discuss the both in details. First, discuss the positive side to the P region and negative side to the n region. This is called the forward bias. So I am going to explain first the forward bias. Forward bias. First there is let's draw a rough diagram. These are basically rough diagrams. The more accurate diagram I will upload on the Facebook page. You must follow our Facebook page. For example, this is the PN junction, and there it is a metallic leads, and there I use is a resistance here. This is a resistance, and for example I connected like a battery, positive negative terminal. You can voltage source we bias. This is a biasing voltage, and metallic leads were connected to the metallic leads, and this is the resistance, and used for the limiting the voltage not to damage the PN junction. It basically controls and in limit the voltage, so it is called the R limit. It limits the voltage in the range of the PN junction, and safe in the safe region, not to damage the junction. To bias the diode, we basically need to apply the DC voltage across it. Forward bias is the condition in which current flows through the current basically flows through the PN junction. I had drawn this diagram, and this shows a DC voltage source connected to the conductive material via wires, as you can see that. This external source is V bias, explaining again, and this is the resistance limits the forward current to a value that will not damage the diode, so it is called the R limit. One thing you have to notice that the negative side of this is the first condition. There are two conditions. First condition is the positive side must be connected, this side connected with the positive. P is stand for positive and stand for negative. Positive side must be connected with the positive P terminal, and N negative side of V bias is connected to the N region of the diode. This is the first requirement for the forward bias. If you didn't connect in this sequence, then it will become the reverse bias, the other condition that I will explain in the next episode. So this is the first requirement. Second requirement is also very important. Two requirements required. The second requirement is the V bias that I am using. The V bias must be greater than 0.7 volts. As I already explained in my previous videos, that why it should be greater than 0.7 volt, because there it is a barrier potential. There is a barrier potential. We use a silicon. For silicon, it is a barrier potential is a 0.7 volt at 25 degrees C room temperature. So if we want to pass the current from this PN junction, we must have enough additional volts to overcome the barrier potential and jump from the barrier potential and move forward. For example, let's explain this simple case. For example, this is a road. If we want to move from one side to the other side, there is a resistance or a hill or a small. For example, there is a bridge. If our vehicle have enough additional power or enough energy to overcome this bridge, then we will reach here. If we have not enough, if we have not an ability, if our vehicle has no ability to overcome this resistance or bridge, then we will definitely not able to reach our destination. So same is the case, like if we are below the 0.7 volts, then we are not, the electrons in this case are not able to cross or jump the barrier potential, and they will not reach to the destination. So the basically I fundamental of the a fundamental picture of what happens when a diode is forward bias is explained by in there, and I will explain the next things later. This is the first video of this chapter and introductory video. What happens next will be uploaded in another part or in the next episode, because the reason is that the uploading problem happens sometimes because this is the 1080p resolution and the internet connection here, I have not a very good internet connection, so it will take some time for me if the length of the video increases. So I will stop the first episode here, and if you have any problem, then write the comments, and suggestions would be appreciated. Thank you very much.